So in this session, we will consider factoring, and to be more precise, factoring of polynomial expressions. Okay? So in here, if we recall, in the integer case, if you have two integers, say 31 and 29, okay, we can easily compute their product. Well, you can use your calculator to multiply 31 and 29, but even in the long hand, meaning if you do it manually, you can easily get this 899 as the product of 31 and 29. So just a quick illustration, if you multiply 31 and 29, what you do, well, you just have here 9, and then 9 times 3, that's 27, and then here 2 times 1, that's 2, and then 2 times 3, that's 6. So you will end up with 899. That is if you are given two numbers. You can multiply them easily. Even if you have 4 digits by 4 digits, 5 digits by 5 digits, you can do that by hand without even using your calculator. It will take time, of course, but at least you can do it by hand. Okay? So multiplication of two numbers is easy. But what if, in here, these two numbers, well, as you already know, or as you might have remember or know, 31 and 29, we call these factors. Okay? So this is left factor, this is right factor, and I think I've been using these terms. Okay? Now, suppose we reverse the problem. Suppose you are given the number 899. Okay? So the problem is, can you find the sum factors of 899 such that if you have those factors, when you multiply them, you get 899, of course. Okay? So find two numbers whose product is 899. Of course, we know it's 31 and 29 in here. Are there other factors? That's the next problem. If you can find them. Okay. So this is not easy. If you did not see this part here, it might take a while to find this 899. In a sense, maybe 10 minutes, 15 minutes, etc. You just have to keep on searching for a divisor for 899. Okay? But the main goal is, how do you do this factorization? So, and if you know how to do factorization, the question is, how fast can you get the factorization? For example, for this guy here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. How fast can you get the factorization of this number? Okay? If you try to do the factorization, you will end up with this. 2 times 3 squared times 5 times 3,607 times 3,803. Okay? So if you have this number, usually, if you need to get a factorization of the number, you divide by prime numbers, correct? You start with the lowest prime number, that's your 2. So if it is divisible by 2, then you divide it by 2. And then you will get a number, check if it is again divisible by 2. If it is, divide that by 2. So you now have 2 times 2. If not, if it's no longer divisible by 2, you move up. You move to the next prime number. Divide by 3. If it is divisible by 3, divide it so that you will have 2 times 3. Okay? If it is not divisible by 3, you move up again to the next prime number, which is 5. Then you do the process. You continue moving up until there are no other prime numbers, or the last number that you get is a prime number. But if you look at this, You have 2, 3 squared, 5. So you divide 2 for the first time, it's divisible. You try to divide it by 2 again, it's not. So you move to 3. You divide by 3, it's divisible. You divide by 3 again, it's again divisible. You divide by 3 for the third time, it's no longer divisible. So you move to the next. You divide by 5, it's divisible. You divide by 5 again for the second time, it's no longer divisible. You move to 7. You divide by 7, it's not divisible by 7. You move again, 7, 11. But take note, here you have 5, and then the next prime number, it's 3,607. So there's a lot of prime numbers to check from 5 to 3,607. Okay? And students will just give up. Oh, maybe this is already a prime number. So they will stop. And then eventually, say, if you continue doing the process, you have here from 3,607, then the next prime factor of this, it's 3,803. Okay? So you will do the process. Okay? So you check each prime number. But the problem is, what is the next prime number? For the first few prime numbers, it's easy to get. You have 2, 3, 5, 7, and then 11. You see, you skip 9 because 9 is not a prime number. You go to 11. And the next one is 13. Then you have, you think 15, but 15 it's not prime. So you go to 17. 17 is prime, 19, and then 21 is not prime. You have 23, and then the next prime from 23 would be 29, etc. So you see, the location of the prime numbers, it's not fixed. It's not just plus 2 or plus 5 or etc. whatever. Okay, so I hope by this illustration you would realize that indeed factoring is really a hard problem. And you are here in the integer case. Well, it's really hard for the integer case. Okay, so what about considering polynomials? So what is this factoring polynomials? How do we factor polynomials? That's what we will learn um, in this lecture. Okay, so for example, we have 2x minus 5 times x plus 2. You have these two binomials, you multiply them, you'll get this polynomial, 2x squared minus x minus 10. So as in before, this is left factor, this is right factor, and this is the product. So the polynomials on the left side are called factors of the polynomials on the right side. Now, the process of finding the factors of a given polynomial, so you have this polynomial and you want to find the factors of this polynomial, of course, we call it factoring. Okay? We call it factoring. Now, in here, we will only consider factoring polynomials in one variable. Okay? In this particular lecture. Okay? And then we factor these polynomials into products of polynomials, of course, in also one variable. But take note of this, where all the coefficients are integers. Okay? We want the coefficients of the polynomials to be integers. If we will consider non-integer coefficients, then there could be infinitely many factors. Okay? There could be infinitely many factors. So we will only consider integer coefficients. Okay? So in all the illustrations that we will see later, we will only consider one variable. But this does not stop us from considering two variables, okay? Or three variables. Maybe at most two variables only, okay? But in all the illustrations that we will have for this lecture, we'll only consider one variable, okay? So we call this factoring over integers. So the coefficients are integers. So factoring over the integers. Now, of course, if you have a number, you multiply it by 1 and negative 1, you'll just get the number or the negative of that number. Okay? So any polynomial can be written as a product of 1 times itself or negative 1 times itself. Okay? So here, if we have p of x, then this p of x can be written as 1 times p of x, or you can write it as negative 1 times negative p of x. Okay? So 1 times itself or negative 1 times the negative additive inverse or the additive inverse. I mean, the additive inverse, it's the negative of the polynomial. Okay? So if a polynomial cannot be written as a product to other polynomials, excluding 1 and negative 1, we say that the polynomial is prime. Okay? So if you have the integers, the intuitive definition or the usual definition that we have, a number, an integer is prime if the only factors are 1 and itself. Okay? So for the polynomials, we have 1, we also include negative 1. So the only factors of a polynomial is 1 or negative 1 and itself or the additive inverse. Then the polynomial is called prime. Okay? So for example, these polynomials here are prime. If you have ax plus b, okay, where a and b are integers, of course, and they do not have a common factor, then ax plus b will be prime. Okay? For example, you have 2x plus 1, okay? Or maybe 4x plus 5, 4x maybe plus 9 or plus 11 or plus 9, let's say plus 9. So ax plus b and the coefficients a and b, they are integers here and they do not have common factor. 2 and 1 do not have a common factor. 4 and 9 do not have a common factor. Okay, so these guys here are prime. Um, Examples of not prime in here. You have here 2x plus 6. This is not prime. Or you have, say, 14x plus 7 or even minus 7. Let's put minus 7. Okay? So not just plus, you also have the minus. But you see 14 and 7, they have a common factor. 7 is a common factor. Okay? So these are not prime. 2 and 6, common factor, it's 2. Or even if you have, say, 4x plus 6. 4 and 6, they have a common factor. The common factor is 2. So these polynomials are not prime. So again, ax plus b is prime if a and b are integers, of course, and a and b do not have a common factor. Also, ax squared plus b, this is also prime if a and b are integers and do not have a common factor. For example, you have your So in here, this number here, x squared plus 1, this is prime. You have a equals 1, b equals 1, okay? But take note of this, excluding 1 and negative 1, okay? So we will consider this to be prime. 1 and 1, their common factor only is 1. But we don't consider that, okay? So in here, this is prime. You can have 5x squared plus maybe 5 and 4. This is, they have no common factor, okay? Now, unlike in the first case here, we can consider minus b. For this, we don't consider minus b because there are possibilities where ax squared minus b is not prime, okay? So these two guys here are prime, okay? If a and b have common factors, then it's not prime, okay? Now, if the polynomial has been written as a product consisting only of prime factors, we say that it is factored completely. So you have a polynomial, you were able to find all the factors, okay? And then you write that polynomial as a product of those factors. Then um, we now have we have factored the polynomial completely, okay? So the question is, how do we factor these guys, these polynomials completely? Okay, let us start with the first method, identifying common monomial factors. Okay, identifying common monomial factors. So you check, so for this method, you check all the monomials and check whether there's common factors. Okay, so for example, here 3x plus 9. The monomial is 3x and then 9. 3x, 9 here. Factors of 3x, 3 and x. Factors of 9, it's 3. Well, 9 is equal to 3 times 3. So you see that for this factor and this, for this monomial and this monomial, 3 is a common factor. So you have 3x plus 3 times 3. 3 times 3, it's 9. And 3 is a common factor. So you can factor that out. So if you factor that 3 out, you will rewrite this 3x plus 9 as 3 times x plus 3. And this guy here now is factored completely. Okay? We have here 2x minus 12. So 2 times x. In here, you have 12. 12 has several factorization. You can have 3 times 4. You can have 2 times 6. You can have, what else? Yeah, those are two factorizations of 12. But 12 has a unique factorization. That is 2 times 2 times 3. Okay? So if you look at that complete factorization, you see that 2 is actually a common factor of 2x and 12. So you can rewrite this 12 here as 2 times 6, okay? Because we will only need the 2, okay? So in here, 2 is a common factor, and therefore you can factor that out. So this 2x minus 12, you can write it as 2 times x minus 6. Okay? For this 4x squared minus 8x plus 16. You have 4 times x for this term here. For this term, you have 8 times x. And then for this, you have 16. But 8, you can write it as 2 times 2 times 2. You can write it as 2 times 4. Okay? For 16, you can write it as 2 times 2 times 2 times 2. Or you can write it as 4 times 4. You can also write it as 2 times 8. Okay? So there are several ways to write the 16. But what we're going to do is to look for the highest possible common factor. Okay? And in this case, 4, we have a 4 here. We can also get a 4 from 8. That's 2 times 4. And we can also get a 4 from 16. That's 4 times 4. So that we have the following. We have 4 times x squared minus 4 times 2x plus 4 times 4. So as you can see, 4 now is obviously a common factor. And then you bring it out, you factor that out, you will get 4 times x squared minus 2x plus 4. Okay? If you look at this term here, 2x and 4, it seems that it has, or they have a common factor, which is actually 2. But take note, you have the x squared here. And you don't see a 2 as a common factor for x squared, for 2x and 4. Okay? So only this guy here from the original expression can be factored out. Now, I must say, believe me that this x squared minus 2x plus 4 is already a prime polynomial. Okay? So just believe me for now that this is a prime polynomial. In the future, we will know that this guy here is indeed a prime polynomial. Okay? So, any questions so far? Okay. Next problem here, we have x cubed plus 3x. So in here, you don't see, well, the coefficient of x cubed, it's 1. The coefficient here, it's 3. And 1 and 3, they don't have a common factor, in a sense. Okay? Of course, 1 is a common factor, but we do not include that. But your x cubed, you can write it as x times x times x. Or you can write it as x times x squared. And then here you have x also. So x is a common factor. Okay? So this guy here, you can rewrite it as x times x squared plus 3x. And you can immediately see that x is a common factor. So you can factor out x here. And we get x times x squared plus 3. And this guy here, x squared plus 3, as I have said, this is now prime if we use the, the hint that was given in the previous slide. So x squared plus 3, this is prime. You have 1 here, you have 3 here, and except for 1 or negative 1, 1 and 3 do not have a common factor. So this is now the complete factored form of x cubed plus 3x. Okay? Let's look at this. We have x to the 4 minus 5x cubed. So here you have x to the 4. You can write it as x times x times x times x. You can write it as x times x cubed. You can write it as x squared times x squared. You can also write it as x times x squared. Okay? And then in here, you have 5x cubed. And again, your x cubed, you can rewrite it in another way. But as I have said before, you look at the highest possible common factor. So this x to the 4, you can write this as x times x cubed. And we are using that factorization for x to the 4 because here I have x cubed also. So the highest common factor is x cubed. So we have this x cubed times x minus 5 times x cubed. And now we can factor out the x cubed because it's a common factor. We will have x cubed times x minus 5. Okay? Here we have 4x squared minus 6x. Okay? So if we look at the coefficients, we have 4 and 6. And both of them are divisible by 2. So 2 is a common factor. Furthermore, if you look at x squared and x is a common factor. X squared, it's x times x. So in here, we have this 4x squared. We can write it as 2x times 2x. We got the 2 and x because 2 and x is also a common factor of 6x. In fact, we write 6x as 3 times 2x. So we can see clearly here that 2x is a common factor. So we can factor that out. And therefore, we have 2x times 2x minus 3. Okay? So this is the complete factored form of this expression. Okay? Now, some students only write the following. They only see the x and therefore they will write this as x times 4x minus 6. This is not complete factored form. This is not in complete factored form. Why? Because 4x and 6, they still have a common factor. 2 is a common factor of this. So you can still factor out the 2. So if you do that, you will end up with this expression. Okay? So if I ask you to find the complete factored form of a polynomial, there's only one answer to that. Okay? There's only one answer to that. Unless you consider the negatives. But, if there's a negative, you won't have negative over negative or negative times negative. But what I'm saying, if we exclude 1 and negative 1, then there will be a unique complete factored form. Okay? So questions in identifying common monomial factors.
Okay, sir.
Yes.
For number 5,
Yeah.
it shows x4 minus 5x3. You put equals x3. Can you explain that, sir? Because I'm a bit confused.
Yeah, because in here, you see, if you multiply x3 and x, or x to the power 3 times x,
okay,
that's x to the power 4.
oh, okay,
Okay.
perfect. Okay,
Yeah.
I understand. Thank you.
You're welcome. Other questions? So that's for identifying common monomial factors. Let us now consider other ways of factoring. So from the last lecture, you remember this difference of two squares? Okay? So we have a formula for the difference of two squares. And then here, I will introduce the sum and difference of two cubes. Okay? So for the difference of two squares, you have x squared minus a squared. Okay? And if you factored this, you have x minus a times x plus a. So remember, from before, we started from this side. So what is x minus a times x plus a? We did the FOIL method, and we will obtain this guy here. So if we reverse the process, you start with this, you'll able to get this guy here. Okay? For the difference of two cubes, so you have here, this will be a new formula. So I want you to remember this. So you look at this. You start with the x minus a, and then the other expression will be in terms of your x and a in here. So you will have x squared plus the product of ax plus a squared. Okay? So again, you have x cubed minus a cubed. The first factor will be x minus a. So you just remove those cubes there. The second factor will be the square of the first term plus the product of the terms in here plus the square of the second term. So take note of the coefficient here. Okay? It's just 1. It's just the product of these two guys. Okay? If it were plus, okay, if were plus, you will have x plus a as the first factor. Okay? And then same process as in before. But this time, the middle part for the x cubed plus a cubed, the middle part of the second factor will be minus. For x cubed minus a cubed, the first factor, it's x minus a. The second factor, everything is plus. For x cubed plus a cubed, the first factor, it's also plus in here. The second factor, you have alternating signs, plus, minus, plus. Okay? And same strategy. Square of the first, plus or minus, product of the two terms, then plus square of the second. Okay? Let's look at these examples here. You have x squared minus 9. You have x cubed plus 8. You have x cubed minus 27. And you have x to the 4 minus 81. Let's start with x squared minus 9. So take note, your 9, it's a perfect square. Okay, take note that this a here, it's a positive integer. So you are squaring it, meaning the term in here must be a perfect square. 9 here, it's a perfect square. It's actually x. So this guy here, x squared minus 9, you can rewrite it as x squared minus 3 squared. So 9, it's equal to 3 squared. And therefore, you can now have the factor x minus 3, x plus 3. Okay? So straightforward application of these formulas here. So you have here x squared minus 3 squared, and therefore you have x minus 3, x plus 3. Okay? Next, we have x cubed plus 8. So take note, 8 here, we need a perfect cube. So this is plus, so we use this third formula here. But we need a perfect cube. 8 here, it's actually 2 times 2 times 2. Or it's actually 2 cubed. Okay? So x cubed plus 2 cubed. So we can now apply this formula. Okay? So if we do that, we have here x plus a, so that's x plus 2. Then square of the first term, that's x squared. Since this is plus, the other guy here will be minus. And then the product of the two terms, so 2 times x. And then square of the second term, that's 4. So this is the complete factored form of this x cubed plus 8. Okay? And I am already declaring that this is the complete factored form. This guy here, x squared minus 2x plus 4, it's a prime polynomial. So you cannot factor that anymore. So I will again um, give you a hint later why this guy here is no longer factorable. Okay? Next, x cubed minus 27. So if you look at this, 27 here, it's a perfect cube. This is actually 3 times 3 times 3. 3 times 3 times 3. So here we have x cubed minus 3 cubed. So this is minus here. We apply this formula here. So we will have x minus 3 for the first factor. For the second factor, we have the square of this. That's x squared. Then since this is plus, we have, this is minus here. We need to use plus for the other factor. And then we multiply the two guys. So that's your 3x. And then the square of 3. That's 9. Okay? Then lastly, for this, x to the 4 minus 81. It seems like it's not in this guys. But take note, x to the 4, you can write it as x squared times x squared. Or you can write it as x squared squared. Correct? So you can change this to something like this. 81, it's a perfect square. It's 9 times 9. So we can write this. We write this guy here as x squared squared minus 9 squared, which means it is of this form already. And we use this formula. So we have this guy here, x squared, and then minus 9, and then x squared plus 9. So according to this formula. So this x squared plus 9, it's already prime. Okay, just like what I mentioned in the earlier. But for x squared minus 9, it's possible that this is not yet prime. In fact, it is not prime because you have your x squared, you have the minus, and 9 is also a perfect square. And if you look at the first example, it's actually that guy there, x squared minus 9. And we were able to factor it as x minus 3 times x plus 3. So if you are just going to look at the first example here, this guy here can be still factored into the following. So x minus 3, x plus 3, x squared plus 9. So this guy here is the complete factored form of x to the 4 minus 81. Okay? Questions?
Wouldn't you have to factor off the last one though, the x squared plus 9?
Like I mentioned earlier, this x squared plus 9, it's no longer prime. It's already prime, I mean. It means you cannot factor that. Okay, so if we go back to that particular slide, um, let us see. So this, you have ax squared plus b. It is prime, okay? It is prime if the integers a and b, if a and b are integers and they do not have a common factor. And in our example, the integers there were 1 and 9. And again, um, we do not consider that to have a common factor. 1 is actually a common factor, but we don't consider 1. So this guy here, x squared plus 9, it's no longer factorable. Okay? Other questions? So the real um the real uh well the hint that I was telling you earlier, the one that how to identify whether this guy here or this guy here is no longer factorable. Okay? If you have your x squared plus bx plus c, or maybe ax squared plus bx plus c, how to know if this is already prime? You look at the following. Okay? If b squared minus 4ac, if this is not equal to 0, okay? In fact, if b squared minus 4ac, yeah, well, if b squared minus 4ac is not equal to 0, then ax squared plus bx plus c is prime. Ax squared plus bx plus c, this guy here is prime. So basically, you just need to compute for this guy here, b squared minus 4ac. You have ax squared plus bx plus c. These are coefficients, a, b, and c. These are coefficients. So if you look at this, and it is not equal to 0, then it's already prime. We call this number discriminant of this expression here. Okay? But we'll do that, more of that later in the course. Okay? So what about that? We look at this. You have this polynomial here. You have this um, x squared minus ax plus a squared. Okay? Of course, you are assuming here that a is greater than 0. Okay? So if you look at this, okay? If you look at this, you have b squared minus 4ac, correct? In this equation here. The b here, it's your negative a in here. Okay? Well, to avoid confusion, okay, I will change the case of these um, coefficients. So instead, I'll be using capital A, capital B here, and then capital C here, which means that this guy here, we just use the capital letters. So this is b squared minus 4ac, and therefore this guy here. Okay? So if we use this now, in this, we have to check. We have to check that b squared minus 4ac. But your b, your capital B here, it's negative a. So negative a squared minus 4. And then what? Your capital A, it's 1. Okay? So times 1. Capital C, it's a squared. Okay? So this guy here, it's a squared. So if you compute for this, you will have a squared minus 4a squared. This is equal to 3 or negative 3a squared, correct? But a is positive. So this guy here, minus 3a squared, it's not equal to 0. This guy here, this is not equal to 0. So this is prime. Similarly for this, your capital B, for this, it's equal to 0. Of course, your capital A, that's just 1. And your capital C, that's 9. So b squared minus 4ac, this is just negative 4 times 1 times 9. And this is equal to negative 36. This is not equal to 0. So this is prime. So this is the hint. You would know if your expression capital AX squared plus capital BX plus C is prime if this guy here, it's not equal to 0. Okay? If it is equal to 0, then this expression can still be factored. And we will have a way later how to factor this type of expression. Okay? You can check this guy here. This is not 0. In fact, we have checked already this guy and this guy via this formula. Okay? Via this formula. So definitely this guy here and this guy here are prime. Okay? Another example here, we have 8x cubed plus 1. Okay? Now, if you look at this, particularly the 8, remember that 8, it's 2 times 2 times 2. It's 8 cubed. So you have 8 cubed plus 8 cubed times 8 cubed. 8 cubed times x cubed. Or you can, sorry, that's wrong. You have 2 cubed, that's your 8. Okay? So that this 8x cubed, it's equal to 2 cubed x cubed. And therefore, this guy here, it can be written as 2x quantity cubed. Okay? So we have this 2x quantity cube. And of course, 1, it's just 1 squared. That's also equal to 1 cube, 1 to the 4, etc. But we just use the 1 cube. So this guy here, it's a sum of 2 cubes. So we can apply our formula from there. You look at this. You have 2x plus 1. That's why you have here. And then for the other factor, you square this. That's why you have here 2x squared. Then since this is plus, you have minus in here. And then you multiply the two guys, 1 times 2x. So you have 1 times 2x plus the square of this. That's why you have 1 in here. And if you simplify this, you will have 2x plus 1 times 4x squared minus 2x plus 1. Okay? Now, looking at this, is this a prime? Is this a prime polynomial? Let's check. Your A here, this is equal to 4. Your B here, that's equal to -2. And your C here, that's equal to +1. So B squared minus 4AC, you have -2 squared minus 4 times A, which is 4 times 1. So this is 4 minus 4 times 4, that's 16, times 1, of course, that's still 16. So this is minus 12. And again, this is not equal to 0. So this is prime. Therefore, this is the complete factored form of this expression. Okay? Questions? So if you would ask me, do you need to remember the formulas? Of course. You will have to remember these formulas. Okay? As well as the other formulas that we had before. It will help you if you remember these formulas. Now, we factor perfect squares. So remember the perfect squares. We have a formula in order to find the square of a binomial. So we just reverse the process. So recall this, x minus a squared, that's x squared minus 2ax plus a squared, or x plus a squared, that's equal to x squared plus 2ax plus a squared. So what if you are given this guy here? Okay. So how do you go back to this? You just use this formula. You need to identify that clearly. And if you look at this, okay, or this guy here, look at this. Your capital A, let me use another color here. Your capital A, that's equal to 1. Your B, that's equal to 2A. Your capital C, that's your A squared. And what's your B squared minus 4AC? So B squared, you have 2A quantity squared minus 4 times 1 times A squared. That's your C, correct? But this guy here, what is this? If you square 2A, that's 4A squared. Minus 4 times 1 times A squared, that's 4A squared. And this is equal to 0. So this guy here, it's factorable. And the factor is given by this. For this special trinomial. Okay? So perfect square. This guy here, the complete name is perfect square trinomial. It's a trinomial because you got 3 terms here, and it's actually a perfect square if you factored it. Okay? Of course, if you have, so we did this plus part. If you have the minus, b will be negative here, but again, you'll just have negative 2a squared. So that negative will disappear after squaring. So you will still get this guy here. Okay? Here are the examples. So you have to identify immediately if it is a perfect square trinomial. Okay? If you cannot identify immediately that this is a perfect square trinomial, of course, there will be other ways. I will teach you that later. But for now, for the sake of using this formula, let us try to identify, let us try to factor this using the formulas. So for the first one here, you have x squared plus 6x plus 9. You can rewrite this 6x as 2 times 3 times x. And then the 9, it's 3 squared. So in here, you can see that this is of the form x squared plus 2ax plus a squared with a equals 3, correct? A equals 3. So this guy here and this guy here. And therefore, you can now write this as x plus 3 squared. Similarly, for this, 4x squared minus 12x plus 9. So for this, you need to identify that it's of this form. You see, though this does not have a coefficient, I mean the coefficient is 1, similarly for this, and that's why the coefficient here is 1. But for this, you have 4 as a coefficient of x squared. So you just need to identify or to determine whether this guy here as a whole can be written as a square of something. But yes, it is. For x squared, you can write this as 2x quantity square. So in here, we can rewrite this expression as 2x quantity squared minus 2 times 3 times 2x. You look at that, plus 3 squared. So this is of the form, so instead of using x, I'll be using y. So this is of the form y squared minus 2ay plus a squared with, okay, with y, this is equal to 2x, and then of course a, this is equal to 3, correct? Y is equal to 2x, a equals 3. So if you see that, 2ay, so 2 times a, which is 3, times y, which is 2x. So 2 times 3 times 2x. Y squared here, y is equal to 2x, so you have here 2x squared. Okay? So following this formula here, y squared minus 2ay plus a squared, this is just y minus a quantity squared. But then again, y, that's your 2x. So you should end up with 2x minus your a equals 3. So 2x minus 3 and then squared. So this is the factored form of this expression here. Therefore, that's what we have in here. Okay? For this example here, 25x squared plus 10x plus 1. Similar method as in this guy. Identify that 25x squared could be written as a square of something with integer coefficients. But yes, it is 25. It's 5 squared. So this guy here, you can write as 5x quantity squared. So 5x quantity squared. And your 10x, you can write it as 2 times 1 times 5x. And then, of course, 1, it's just 1 squared. So you have that 1 in here. And then just like the method from earlier, you can just maybe replace 5x with another variable, say y. So this is y squared plus 2ay plus a squared. So using the formula, you will end up with this 5x plus 1 quantity squared. Okay? Questions so far?
Could we have only put like the 2 multiplied by 5x instead of the 1 in the middle?
Yeah, sure, you can do that.
Okay.
You can do that. Other questions? Now, as I have said, if you cannot recognize immediately that this is a perfect square trinomial, this guy here and this guy here, and even these guys, even if the coefficient of x squared is 1, there are other methods uh, to factor these this type of expressions. So we will discuss them. Okay. The first way will be called the factoring by grouping. Okay, factoring by grouping. And for this method, you can also use this even if you have higher powers for your x. In the previous methods, we just had like the formulas that we had. We have difference of two squares and then perfect square trinomial. So that deals, or those deal with squares with the highest power 2. Okay? And then we had formulas for difference of two cubes and the sum of two cubes. So those two formulas deal with degree 3 expressions. For factoring by grouping, okay, this method deals with any possible degrees as long as this method is applicable. Okay, as long as this method is applicable. So how is this guy here used? If a common factor cannot be found in every term of the polynomial, but occurs in each several groups of terms that make up the polynomial, then the common factor can be factored out of each groups using the distributive law. Okay? So this technique is called factoring by grouping. So in the method of factoring by common monomial, you only look at monomials. What is the common term? Or what is the common factor for each monomial? For factoring by grouping, you group monomials. Could be binomial, you can group trinomial, etc. You group those monomials and then try to check whether there will be common factors as a group. Okay, that's why it's called by grouping. Okay, so these are the examples that we will consider. Okay, and they are written already so that the grouping will be obvious. Okay, so for the first one here, you have A. So this is x times x plus 1 squared minus 3 times x plus 1 squared. So as a group, you have here x squared plus 1. Here you have also x squared plus 1. Also, wait, did I mention the correct, or did I say the correct expression here? If not, let me just state them. So the expression is x times x squared plus 1 minus 3 times x squared plus 1. So you have the grouping here, x squared plus 1. You also have the grouping here, x squared plus 1. And observe that x squared plus 1, it's a common factor for this expression and this expression here. So you can factor out that x squared plus 1. So if you factor that out, what will remain is this guy here, x minus 3. That's why you have here x minus 3, x squared plus 1. Okay? Questions? Now, for the second one, you have here 9x squared minus 6x plus 3x minus 2. Of course, if you look at this middle guy, they are already decomposed, but possibly in actual problems, what you will only see is 9x squared minus 3x minus 2. Correct? Because minus 6x plus 3x, that's equal to minus 3x. So in an actual problem, you would see something like this. Okay? So if you have something like this, maybe the question is, can I actually find this decomposition of minus 3x? The answer would be yes. And I will teach you how to do that later. For now, suppose we were able to do that. Suppose this minus 3x, we write it as minus 6x plus 3x. And hence, we have this problem. Okay? So, if you do this, what you can do, so I have decomposed it into minus 6x plus 3. What we can do is to group these two guys here. Okay? We group this together. And also we group this together. Which means what? If we do that, we have these quantities. So group 9x squared minus 6x plus you group 3x minus 2. If you look at this, there are common factors as a group. 3 is a common factor because 9 it's 3 times 3. 6 it's 2 times 3. So 3 is a common factor. And of course, x is also a common factor. You have x squared here, you have x here, so you can factor out x. If you do that, you will be able to factor the 3x. And if you factored out 3x, what will remain inside the parenthesis is 3x minus 2. Follow? Okay? And now, you can see here 3x minus 2. There's also 3x minus 2. Keep in mind, this group here, this is actually multiplied to 1. 1 times 3x minus 2, it's just 3x minus 2. So, you can factor out your 3x minus 2. Okay? And what will happen is once you factor that 3x minus 2 out, you will have the other factor as 3x plus 1. So again, that plus 1 came from this part here. So you have this 3x, and then you have that plus 1. So that's your 3x plus 1 after you factored out this 3x minus 2. Okay? Questions? Next.
Sorry, I have a quick question. What happened to the -2 in the second to last line?
Well, it's there. You have your 3x minus 2, 3x minus 2. That's your 3x minus 2 here.
Okay, okay.
Yep.
Thank you.
That's your common factor, 3x minus 2.
Oh, but sir, there's 2 minus 2's in the line before that one.
There's no 2 minus 2. I don't see a 2 minus 2.
No, I mean, sir, there's -2 twice in like the one that you're looking at now.
This guy here.
Yeah, and then there's the one next to it there.
Look, if you, for example, let us go back to one step in here. It's like in here, you got 3x times a plus 1 times a. Where a, okay, where a here, this is your actual 3x minus 2. Do you see that?
Yeah, that's it.
And therefore, you can factor out the a, correct?
Yeah.
That's your 3x plus 1 times a. Do not be
Oh,
confused. They are not separated. They are actually part of the group. This negative 2 here
oh,
and then
okay,
this
I get
negative
it.
2. Yeah, it's
Thank
part
you.
of the group. Okay? Other questions? Next, for this example, 3x squared minus 3x minus 2 plus 2. So again, if you look at this, it's already decomposed. So minus 3x minus 2x. In an actual problem, they are joined together as minus 5x. Okay? But anyway, so how do we do this? So I have separated them this way. We can now start the grouping. So you have here 3x squared minus 3x minus quantity 2x minus 2. Take note of that. In here, you have minus 2x plus 2. But you are grouping them, and you have that minus here. That means you have to make this a minus. So that if you distribute this negative here, here, and in here, of course, minus times 2x, that's your minus 2x. Then minus times negative 2, that becomes your plus 2. So when you factor out a negative sign, be sure to change the signs of the group. Remember, when you have a negative sign and then you have the grouping, when you distribute that negative sign, you change all the signs inside the group. That's the same thing as when you factor out a negative sign. You also have to change the signs inside the group. Okay? A lot of students commit mistakes on this type. They just group this without considering that after grouping and this is minus, there should be a minus coming out. Okay? So be careful on that. And now, let us look at this. In here, you have 3x squared minus 3x. Definitely 3 is a common factor. Your x is also a common factor. So you will be able to factor out the 3x on this group. On this group, you will be able to factor out the 2 because you have your 2x and then the 2, you have your 2 in the 2x and the 2 here. So you can factor out the 2 in this group. So you will have 3x times x minus 1. So after factoring your 3x here, you will have x minus 1. And in here, if you factor out the 2, you will have this x minus 1. And now, as you can see, this guy here and this guy here, it's a common factor, again, as a whole. So you can factor that x minus 1 out. And if you do that, you will end up with, so this is your x minus 1, and then in here you have your 3x minus 2. That's why you have your 3x minus 2. Okay? So this is factoring by grouping. Okay? And as I have said, this guy here, you can also do this if you have a degree 3 expression, polynomial expression. And even if you have a degree 4 polynomial expression. Okay? Questions? So at this point, we have factoring by common monomial. We have the formulas coming from the special products. So difference of two squares, difference of two cubes, sum of two cubes. And then we also have the perfect square trinomials. Okay? So those are with the formulas. If we don't have the formula, we can use this factoring by grouping if possible. If you can immediately see the grouping. Okay? If not, then particularly for degree 2 polynomial expressions, we have other ways. Okay? Let's have this first way. Suppose we have this x squared plus bx plus c. This is our polynomial expression. Look, the coefficient of x squared here, it's 1. Okay? The coefficient of x squared here, it's 1. So how do we factor this kind of expression? So to factor x squared plus bx plus c, our goal is to find integers, small a and small b. Look at this, small a and small b, such that if you add those two small letters, a plus b, you will get capital B. And then if you multiply these two letters, you have capital C. Okay? And once you found those letters, small a and small b, your x squared plus bx plus c can be factored into can be factored into x plus a times x plus b. Okay? So you need to find these small letters a and b satisfying this guy here and this guy here. So the question is, how do we do this in actuality? You start with this guy. You start with capital C and try to factor that capital C. So you get two factors of capital C. And once you have the two factors, you try to add them. And you could have several trials and choose the one that satisfies this condition. Okay? For example, we have these expressions here, two factor. Okay? Let's start with the first one. So we want to factor x squared plus 5x plus 6. Okay? So in here, capital B, it's 5. Capital C, it's 6. Okay? So capital C, it should be the product AB. Of course, if you have that capital C, you will now have possible values of A and B. Once you have those possible values of A and B, try to check if the sum is equal to B. So C, it's just 6. Okay? 1 one set of factors of 6, it's 1 and 6. 1 times 6, that's 6. But as you can see, if you added 1 plus 6, it's not equal to 5. Okay? Another possible factors of 6, it's negative 1 and negative 6. If you multiply negative 1 times negative 6, you will get positive 6. And as you can see here, negative 1 minus 6, that's not equal to 5. So this is not the one we need. 6, you can have 2 times 3. Okay? And if you added these two guys here, you will get 5. And therefore, these are the two numbers that we need. Okay? Suppose, these were our trials. Suppose you were not able to try this first. You could have tried negative 2 and negative 3. And you will see that these two guys here fail to have a sum of positive 5. Okay? So this is the correct pairs or correct pair that we need. Okay? And therefore, we have now the factored form of x squared plus 5x plus 6. That's x plus 2 times x plus 3. Okay? So again, you start with the constant term, that's your capital C. You check possible factors of that capital C, and then you add those factors. The one that will satisfy this capital B, those are the numbers that we need. Okay? And of course, if you tried first this pair here, and you have already the correct conditions, or the pair already satisfies the correct conditions, then you don't have to try other possible pairs. Okay, there will be only one. So you can just skip this part. Okay. Next here. Suppose we have x squared minus 7x minus 8. Okay. So capital B, that's minus 7. Capital C, that's minus 8. So again, we need to find possible values for small a and small b such that the product, it's capital C, and here, the sum, it's capital B. So capital C, that's negative 8. Okay? And in here, factors of negative 8, here you have 1 and negative 8. So if you multiply them, you will get this negative 8. And as you can see, if you added them, you will get negative 7. That's our capital B. And so we're done. At this point, you can immediately write the factored form. Okay? But let me just write the other possible pairs that you would have tried. You have negative 1 and positive 8. You have also 4 and negative 2. And you have negative 4 and positive 2. So all of these pairs will give you product equal to negative 8. Okay? But again, just on our first try, we have the correct pair. And therefore, x squared minus 7x minus 8, that's equal to x minus 8 times x plus 1. So we have the correct factored form. Okay? Now, hint. Of course, for the capital C, you would know the pairs. If the sign of capital C, okay, is positive, then the pair, okay, then the numbers in the pair must have the same signs, either both positive or both negative. If the sign of capital C is negative, of course, the numbers in the pair must have different signs, both positive and both negative. That's one. Second hint, suppose the middle part is negative. Okay? If the middle part is negative and capital C is positive, okay? So again, if the middle part is negative and the capital C is positive, then the pair must have both negative. So you can skip the both positive trials. Okay? And of course, if they are all positive, C is positive, middle part is also positive, you only try positive factors. The pair must have the same positive numbers. Now, for this type of example, you have negative C, and as I have said, the pair must have opposite sign. The numbers in the pair must have opposite sign, one positive, one negative. If the middle part is positive, okay, then the higher number in the pair in absolute value must have positive sign. Okay? Must have positive sign. If the middle part is also negative, then in the pair, okay, the numbers in the pair in absolute value, the one which is higher must have negative signs. So what I'm saying is, for example, you have negative C here. The middle part here, it's positive. So you have 1 and 8. The higher number, it's 8. That must have the negative sign. If you tried here, 4 and 2, the higher number is 4. That must have the negative sign. Okay? If this guy here were positive, so plus 7 instead, then 1 and 8, the higher number it's 8. That must have the positive sign. Therefore, you have here negative 1 and positive 8. Okay? Again, if this were positive. If you chose the pairing 4 and 2, and this was positive, okay? And then you must have this 4 positive and the lower number 2 will have the negative. Okay? So just try um, to understand that those hints, you can rewatch the recording and listen to that. But if you're going to do this over and over and over again, you see those hints will be natural to you. Okay? Okay. So let's have this example and we apply those hints that I gave. Okay? But at this time, I will not include this in the recording when I upload this video. So you can work on this on your desk if you are rewatching this video again. So you can now hit pause if that's the case. another example here. This will be the last example for this illustration, okay, for factoring a second degree of this type. So we want to factor x squared minus 3x plus 2, okay? And again, I will do the solution of the record.